Hello everyone, let us now discuss how can we solve this problem. Distribute candies among children. Second question, right? So the first and the second question's difference is just the constants. Now let us understand what is given in the question. You are given two positive integers n and a limit. Return the total number of ways to distribute n candies among three children such that no child gets more than limit candies. Now, let us understand that we are given with three children, right? There are three children and there are n number of candies and there is a limit and a child cannot get more than limit number of candies. Now let us look at an example where n is equal to 5 and limit is equal to 2 and the same thing again is the number of childs are 3. Now for the first child I choose to give 0 candies. Now for the second child and third child I can give, for the second child I can give 1 candy and for the second child the remaining are just 4, right? I have given 1 and we are remaining with 4 and I'll give this 4. But if you see 4 is exceeding 2, so I will not prefer this and this is not the idea that I can give. Now I have one given one candy to the first child and remaining candies are, now let us just start with just 0 and imagine I have given 2 candies to child 2, right? If I give 2 candies to child 2 and I can give only 3 candies to child 3. Now this is also not possible because 3 is greater than 2, right? So this is not possible. Now let us go again and give 3 candies and here 2 candies, and again this is also not possible. So we cannot give 0 candies. Even you can go further and check for 4 and 1. Here it will be 4 and 1 and this will also not be satisfying the constraint that each child should not get more than 2 candies. Now let us give only 1 candy and we are left with 4 candies. N is equal to 5. I have given 1 candy to the first child. I have 4 candies. Now what I'll do is give 1 candy and I will give 3 candies. Totally 5 candies. But this is also not possible. Why? Because 3 is greater than 2. Now what I'll do is just 2 candies and then 2 candies. There are 4 candies and this is possible. Why? Every child is getting here. Every child is getting less than or equal to limit number of candies. Now if I take 3 and 1, again this is not possible. Now I'll go and give 2 candies to child 1 and I have remaining with 3 candies. Now I can give 1 candy, or even if you consider that giving 0 candies and then giving 4 candies, also we can also consider like that. But I am starting with here I have given 0 candies to child 2 and I am remaining with 3 candies. But can I give 3 candies to child uh, 3? No. Why? Because 3 is exceeding the limit of 2. So I cannot give it. Now I have given 1 candy and I am remaining with how many number of candies? 2 candies. And I can give, right? All the candies which are given with are less than or equal to the limit. Now if I give 2 and here I am remaining with 1 and I am giving to child 3 and it is valid. Now if I give 3 and it is 0 and this is not valid. Now can I give 3 candies to child 1? Here itself the loop ends, right? I cannot give 3 candies to child 1. Now what I am doing, I'm just I'm just going from going from 0 to what is the last element that I went? 3. No, it is 2, which is the minimum of limit comma n. So the minimum of limit comma n that I went through. So let me take I is equal to 0 to minimum of n comma limit. Now, what does the second child gets? Second child gets from 1 to 4. But if you see, he can also get, right? I just missed that 0 and then 5 and 5 and 0. So he is iterating from 0 to remaining number of candies. Now, what I said here also 0 and 4, 4 and 0. What I said is if it is lesser than or equal to limit, only if this child is getting lesser than or equal to limit number of candies, then it is a correct way. Now let us go again and write it over here. Let us take j is equal to 0 and it is going from how many number of remaining number of candies. Now what are the remaining number of candies? I have given I number of candies to child 1, so the remaining number of candies are n minus I. Now what does the third child gets? Third child gets n minus I minus j number of candies. If k is less than or is equal to the limit, then our answer increments. If k is less than or equal to limit, then our answer increments, and let us initialize answer is equal to 0. This is what the algorithm looks like, but this will fail for the second part, but second part of the question, right? How do we optimize this? Now if you see, there is a loop, the second loop, the inner loop, right? If I take the array size as n, and this is the first loop, and this is the inner loop, and this is the one which is causing us the time limit or big O of n square time complexity. Now what I'll do is just let us take and we need to just optimize it. Now first thing what I take is n is equal to 15 and the limit is equal to 7. Now let us take something like if I give for the first child, second child and the third child. Now I'll just take for the first child, if I give 0 number of candies, here for the second child, how many candies that I can give? If I start with 0 and 15, no need. I can start with something like, let us start with just 5. I am remaining with 15 number of candies. I have given only 0 candies. I have remaining 15 number of candies. 10, 6 and then 9. No, these are not possible. Why? Because 9 and 10 are greater than the limit which is given as 7. Now if I give 7 and here 8, this is also not possible because 8 is greater than 7. Now 8 and 7, this is also not possible because 8 is greater than 7. And 9 and then 6, this is also not possible. Now what I'll do, I'll just remove this and start again iteration with 1. Now if you see, with 1 I have 14 candies, right? Remaining candies. Now let us just start with 8 and then 7. Sorry, if I start with 5, I have remaining for one thing is I have given one candy to the first child. Now I have remaining with 14 candies. If I give 5 candies, I am remaining with how many number of candies? 9 candies. Now this is also not possible because 9 is greater than limit, and 6 candies. If I give 6 candies, I have remaining with 8 candies, and this is also not possible. I can give 7 and then 7. This is perfect. Now if I give 8, then I will be remaining with 6 number of candies, and 7 is the only combination that I got. Now let us see, let us just remove this and let us make it here, right? And I am starting with giving 2 candies to the first child. Now I am remaining with 13 number of candies. Now let us see. For 13, I will start with 5 again. So if I even go with the 0 until 4, there are no possibilities that I can get a way that I can distribute n number of candies to this 3 childs. Now 5, what are the remaining? If I give 5 from 13 candies, 8, but this is not possible. 6 and then 7 remaining, but this is possible. 7 and then 6, this is possible. 8 and then 5, this is not possible. But if you see, how many ways do I got? 2 ways. If I write it as something like 7 minus 6 plus 1, which is what? 1 plus 1, which is 2. Why? This is also the same thing. 7 minus 7 plus 1. 0 plus 1 is 1. This is the number of candies, that number of ways that I can get if I is 1. Right? If I is 1. Now, let us see what is happening here. What is 7? What is 6? 7 is nothing but, it is not 8. Why it is not 8? Why it is not 9? Why it is not 10? 7 is nothing but our limit. So this number is nothing but, maximum. Let me name it as maximum. Maximum number of candies that I can give to a child is the minimum of limit comma n. Right? Now, if I just go and let me take this as 13 number of candies, right? If I give for the first child, I am giving 13 number of candies, right? Okay. Now the remaining number of candies are just 2, and the limit is 7 and the n is 15. Now, how many number of candies that I can give to this child number 2? That I can give 2 candies and 0 candies. But if you see, if I give firstly with 13 number of candies, that I cannot even go further. So what I'll do is just decrement that, and I will give the maximum number of candies to child. This is the limit. Now if I give 7, the remaining are, if n is equal to 15 and limit is given as 7, and I have given 7 candies. Now the remaining are 8. Now how do we distribute 8 candies to these two childs? 5 and 3, it is okay. Now I have 8. So 7 and then 1. This is also okay. But 0 and 8, this is not okay. 1 and 7, okay. 2 and then 2 and 6, this is perfect. Right? 3 and 5, this is also perfect. 4 and 4, this is also perfect. 5, 3, 6, 2, 7, 1 and 8, 0, this is not perfect. Right? Now, what is the maximum that I got again, which is the limit, right? I can also get that n can be greater than limit. That's why I wrote the minimum of limit comma n. So this number is maxi. Maxi. What is this number? 6. What is this number? If you see, this is 6 and 7 minus 6 plus 1 will be our answer. But what is this 6? Right? If you see, 8 is the remaining number of candies. Now I got 7. 7 is nothing but the maxi. Maxi is the minimum of n comma limit, and limit is 7. Now I got to get 1. But if you see, 8 minus 7 is giving me just 1. So the remaining will be, the remaining will be decremented by maxi. So what I am doing is maxi is equal to minimum of n comma limit, right? Now the remaining are remaining minus max, right? So here the remaining were 8. 8 minus 7 is giving me 1. These are the lower bound, or the first thing that I need to minus. So to get this number, I need to do remaining minus maxi. And how do I get maxi? Maxi will be the minimum of n comma limit. So this is how we solve the problem, and I got remaining minus maxi, right? And answer plus is equal to, I can get a negative value for maxi minus remaining plus 1. Why? Here if you see 0, right? The remaining number of candies are 15 and the maxi that I get is minimum of n comma limit. Minimum of n comma limit which is 7. So remaining are 15. 15 minus 7 is 8. Now if you see remaining is 8 and the maxi is 7. 7 minus 8 is minus 1 plus 1 which is giving me 0. And there are possible cases that this can be going in negative value. So for that case I am taking maximum of 0 comma maxi minus remaining plus 1 and let me initialize answer is equal to 0 for int I is equal to 0, I is less than minimum of n comma limit I plus plus. Now I have given I number of candies to child 1. So remaining will be n minus I. So int remaining will be n minus I. Int max is equal to minimum of n comma limit and return answer at the end. So this is how you solve this problem and I have given the code link in the description. Go and check it, and if you have any doubt please do comment in the comment section, and if you have understood this explanation do like the video and do share to friends and do subscribe to my channel. Thank you.